And the first go, so I'll read it out loud for you and let you guys discuss clearly a conceptual discussion question, right? So it says f of x is not continuous at x equals 2. Which of the following, and I underlined the word, must, as a point of emphasis, which of the following must be true? You have 3 options and only one of them is the correct answer, right? We're not going to be circling more than one. So please take a minute or two, discuss with your friends, see what y'all think. We'll check back in just a minute. As I walked around, one of the common things that we talked about a lot were if you've got these conceptual questions where there's a bunch of words and symbols and no pictures, it might be helpful to try to get some pictures in there, like of a graph. And so the word must, of course, is very, very important. So I'm going to look at A first. We're going to look at a graph of what the function could look like, f of x, if A is it. So I'll just come over here and say this is what a graph of A would look like. Here is 2, and there would be a discontinuity based on that description, right? What kind of discontinuity? A jump. Yeah, different behavior from left and right. It's a jump. So, it maybe looks something like this. I don't know, like that. And maybe one of these is filled in, or maybe not. It doesn't really matter. Or maybe it's one of these guys where that's there. Could be a variety of different graphs that would fit that description. So the question is, if f is not continuous at 2, does it have to be that? No. Does it have to be a jump? No, it doesn't. Could it be a jump? Yes. It doesn't have to be, right? The word must is really key here. So I think we have to say that A is not it, simply because although that could be the case, it doesn't have to be. It's not a must requirement. Okay. Any questions on A? All right, so then B, from a graphical perspective, it says f of x is not defined at 2. So, or you could say f of 2 doesn't exist. That would be another way to say this. So if f of 2 didn't exist, or f of 2 is not defined, what graphical feature or features? A removable discontinuity, or a vertical asymptote. So it could look like, it could look like this, one of these guys where you've got like a hole right there. Or, I'm just drawing 2 graphs on the same graph here. Or it could look like that.
If it was does not exist, like if you're doing that 3 like stipulations for continuous, would that be continuous or not? If your answer was does not exist for all 3, like limit from the left, limit from the right.
Oh gosh. Well, f of 2 has to be defined.
Okay.
So the answer would be no.
Okay.
Yeah, good question. Because they would all like sort of match, but not really because they're all DNEs. Yeah, good question. Okay, so are you guys okay with like the graphical representation there? So then now to answer this question, we have to say, does it have to be one of those 2?
Yeah.
It doesn't. What are we, with B, what possibility are we leaving out?
That there's like a point defined at 2 that's not along the same path.
Well, yeah, yes, but there's like and that could go with like the removable, right?
Right.
And that may or may not be the case. Like you're right, it could be. But what entire classification of discontinuity are we missing if we say that it must be B? Jump. B does not allow for a jump necessarily, right? It could be the case or maybe not. So of course, by process of elimination, if it's not A, if it's not B, it's got to be C. Let's take a look and see how C could actually be the right answer because it covers all of the possible discontinuities. So if f of 2 does not equal the limit, could it not look like this? Here's 2 again. Couldn't it be one of these guys with a removable discontinuity? So that's case number 1, and that fits C nicely. Case number 2, that would be the jump. So like something like this would be the jump. So here, f of 2 doesn't equal the limit because although f of 2 does exist, the limit doesn't. Make sense? And then the last one would be a vertical asymptote. At 2, so maybe you've got one of these guys. There's your vertical asymptote, and then just something like that. Well, here, this is sort of Grant's idea, right? The limit doesn't exist, and neither does f of 2. Right? So only C incorporates all three possible types of discontinuities you could have. A only includes one, C includes two possibilities, only C includes all three possible discontinuities. So if the word must was instead could, wouldn't the answer be all of them? Which of the following could be true? Yeah, we'd have to say, well, any of those things could be the truth, but only C must be true in this case, because C is the most general way of putting it. A and B are just a little too specific.
For A, it has jump, right?
A jump. Yep. Anytime you have different behavior from left and right, but yeah, it's like, I guess now that I'm thinking about it, I guess A, you actually could even like squeeze a vertical asymptote into A, because couldn't you have different behavior from left and right? I guess you could squeeze that one into A as well. It's not really a jump. It's a vertical asymptote, of course. But you have a gigantic jump. I don't know, some of you thought. Only C is the best one. So doesn't it feel like with a question like this, not only is your calculus and math knowledge being assessed, but also your ability to like think through statements and graphs and things like that? It's a challenge. These could be tough questions for sure. All right. Any other follow-ups or anything? Okay, cool. So then please, if you would, take a look at number 2. Number 2 is right here. So this one is a little bit more just like what we did yesterday. So let me just hopefully start you off in the right direction. If I'm asking you to investigate continuity, what better be on your paper somewhere? Limits. Hopefully at the start, you got that one-sided limit statement. And if you need to peek back to yesterday's notes and remind yourself.
Hello, Valor. I apologize for the interruption. This is Mr. Watson. Just please be advised, we're going to go on a lockout. We just need to go on a lockout just for precautionary reasons. We'll be on a lockout. And we'll advise you when we are clear. Thank you.
You guys know what a lockout is? There's potential danger somewhere out there, and so we're like securing our perimeter. We just keep it. It's not a lockdown.
Clowns are running
Right?
wild.
Lockdown means that they're worried that something might actually be in the building that's threatening. Lockout means anything that might be threatening is like, so like let's say somebody robbed a bank down here by King Supers or something. Or if they robbed King Supers, if somebody tried to burglarize something down there and we're aware, oh my gosh, there's a crime potentially going on, we would definitely go and lock out. It's like all the doors would be locked, we're not going to let anybody in.
What happens if we get our
Not until the lockout is lifted. Yeah, so nobody's allowed to like leave or go in and out of the building. Okay, please try number 2. I think they post people at the doors. They would say, no, you cannot leave. It might not be safe for you out there. Yeah. All right, we're working on number 2. It says, show that h of x is continuous for all x. We're going to try to prove this. So like I've said, I think I said it probably 7 or 8 times yesterday. I'll say it a couple more times today. If you're asked to investigate continuity, you must use one-sided limits as part of your process. So I'm going to start off with saying limit as x approaches 4 from the left of h of x. Possibly or hopefully equals the limit as x approaches 4 from the right of h of x, and then that hopefully equals h of 4. So again, look at your paper. Maybe you already have looked at your paper, and if your paper has that on it, that's a great start. Hopefully you finished well. If your paper does not have that on it, you're going to have a problem. Okay? You're not really communicating what the meaning of continuity is unless you have those one-sided limits in there somewhere. I'm okay if you don't do the question marks. I know some people are pickier about that. They should be there, but whatever. Okay, so from the left, we're talking about the line. And so that would be 1/2 times 4 minus 48. I see negative 46 up there for that one. And maybe that equals the limit from the right. So we plug the 4 in. We try the parabola. That'd be negative 48 plus, look at that, it's negative 46. And then, of course, h of 4 is contained within the line, so I think we can say that that also equals negative 46. And because all three of those parts are equal to each other, what's our conclusion?
That's continuous.
Yes, it is continuous. So we could say, are you guys all comfortable with that symbol right there? The little therefore triangle thing? So if it's a little dotted triangle, it means therefore. So we can say, therefore, h of x is continuous. And you could finish this off a number of ways. You could say continuous at x equals 4. Therefore, h of x is continuous for all x, because the two pieces themselves are continuous. Or if you just wanted to jump to this conclusion over here, I'd be fine with that. I'd be fine with either one of those conclusions, because 4 is really the issue here. So, okay. Questions, follow-ups there? Hopefully this is all just good reinforcement from yesterday. That's the goal. All right, so let's move on to 3. Hope this is all making sense to you. So number 3, very obviously, very simple-looking question. Who knows how tough it'll be for you? If g of 3 equals negative 5, what is the limit as x approaches 3 of g of x? Ready to go. Walking around, I think I have a sense of this. How many of you think that for this one the answer is negative 5? Raise your hand. I want to see, just get a sense. I'm committing, I'm jumping in with both feet. The answer is negative 5. Okay. So that's like maybe a fourth of you, roughly. Maybe a little bit more than a fourth. So that means roughly 3/4 of you think it's something else. Anybody want to share?
I want to share.
You want to share?
Why not? You said so.
Who wants to share? What do you think?
We think there's not enough information to determine what the limit would equal.
Okay. So he says not enough info, and a couple of folks over here said something similar to that. Said, we don't know because there's not enough info. Well, let's settle this with a graph. So if I were to sketch this, g of 3 equals negative 5. That would be 1, 2, 3, and 1, 2, 3, 4, 5. That would be, wouldn't that be graphically represented by that?
Yeah.
Okay, so 3 comma negative 5. So then, what does this mean when we're talking about a limit of g of x?
X approaches a certain value of that, or the graph approaches a certain value of x.
Are we looking for the actual value of y or something different? When we're talking about the limit, is the limit asking you, hey, what is the value of y when x is 3? What is it asking you for? Approaching, Isabel's doing this, yes. I like to say pattern. What's the pattern of the y's? What's the pattern of behavior of the y's? So, if you want to say that this limit equals negative 5, wouldn't the graph have to look like this? Wouldn't the pattern of behaviors have to match that y value? And the truth is, we don't know that that's what it does. So, for example, couldn't we draw a totally different graph that perfectly fits the given information, yet the answer is not this? Right? Can't the pattern of behavior be something else completely different from the actual y value? Could be. And so I would say, I'm with you on the not enough info. AKA, as Carson so elegantly put it, we don't know. We just don't know. Right? Because there's not enough information. So, was that a trick question?
Mm-hmm. Yes.
I don't know if that was a trick question or not. I wanted you to think. And I think, listening to your conversations, I think the thinking goal was accomplished. Was the conceptual goal accomplished? You get it? The pattern of behavior of the y's does not necessarily equal the actual y value unless we know that the function is what?
Continuous.
If we know the function is continuous. So wouldn't that be the thing I'd have to throw in here? Like if I tagged this on right here at the end and I said, what is the limit of as x approaches 3 of g of x if we know that g of x is continuous then wouldn't the answer have to be -5? I never said that, though, and so we can't for certain go with -5. Okay, so I got one last one here in this set for y'all to try. It's number 4. This is really similar to one we finished with last time, but it's got a little more to it, right? It's got 3 pieces instead of 2 pieces. So I want you to try to find A and B so that f of x is continuous for all x. And of course, I hope you understand with this one, that means we're really concerned about x equals -1 and x equals 2 and everything else continuous. The different chunks are continuous. It's just about getting the points to join up where they're supposed to join. So anyway, take a few minutes, try this out. Ready to go? So for the blue one up there, that's in regards to -1. And so as I evaluate the limit as x approaches -1 from the left, that would be that sine of pi over 2 function. So wouldn't that be sine of -pi over 2 when I try to evaluate the limit? So I'm thinking that's -1 equals, and then as I approach -1 from the right, that would actually be that ax plus b. Yeah? And so when I evaluate that limit, I would get -a plus b. And the f of -1 was handled with the ax plus b, so I don't need to write that twice. I think we did one kind of like that the other day. The only issue with that is I've got one equation and 2 unknowns. I need to get another viable equation to help me with this, and that's what the red one is all about. So with the red one, as I approach 2 from the left, that would be the line. So I would say that would be 2a plus b. And as I approach 2 from the right, I think that would be the cosine piece. So that would be cosine of 3 pi over 2 times 2, which is really just cosine of 3 pi, which is? -1. Right. Fantastic. Okay. So I got another equation with 2 more unknowns. How do I solve something like this? Substitution or elimination. Either way would work. So maybe I would take this blue one, rearrange a little bit, and say that a minus 1 equals b. Yeah? And then just plug a minus 1 in for b on the other one. So that would look like this. So substitution, I would get 2a plus a minus 1 equals -1. So looky there, it's 3a equals 0. Sometimes people freak out when they see that. What does that mean a is? 0. Okay, so a is 0. We'll talk about, if we have time, we'll talk about that. We might not. But yeah, for sure, a equals 0 is right. Therefore, b equals -1 when you plug back in and get that other coordinate. So if a is 0, what does that mean about that middle piece? It's constant. So what will it look like on the graph?
Straight line.
Not just straight line, horizontal, flat. Horizontal line, right? Because the slope would be 0. It would just be, it'd be y equals -1. It'd be just a horizontal line for that little domain. Okay? All right. No. So let's talk about that real quick. Tomorrow is your quiz. The quiz is only on limits. We have transitioned for the last 2 days talking about continuity. Continuity is definitely not on tomorrow's quiz. It is only about limits.
So
only
29 practice problems.
Those are only on limits. Yep, on concept 1. Yep. So yeah, tomorrow's quiz is on concept 1. That's it.
Is it just day 1 and 2?
I think so. Yep. We've done some reviewing in the subsequent days, so there's other practices we've done, but that's where the material was presented. Yep. All right, have a wonderful day. Love working with you guys. Have a good one.